Kubernetes Gateway API, the complete learning guide. Let's jump right in. Welcome to this explainer. I am super pumped you're here. Today, we're strapping in to tackle a real high-stakes scenario, the exact kind every single software engineer and DevOps pro eventually faces. We're going to master the Kubernetes Gateway API, and we're going to do it step by step.
Picture this, right? Your team has spent weeks, maybe months, sweating over a massive new version of your core API. It passes local tests, it breezes right through staging, but now it's time for production. And you are terrified because a single, tiny misconfiguration means every single user gets an error page. Your pulse is racing, you just want a safe way to test the waters without blowing up the whole system. Well, let's dive into this. What you're desperately looking for is what we call the 5% canary dream. You want to route exactly 5% of your live production traffic over to the new version, just to see if it actually holds up. If it throws errors, boom, you dial it back to 0 instantly. If it works perfectly, you slowly dial it up to 100%. It is literally the ultimate risk reduction strategy. But, historically, in Kubernetes, setting this up has been an absolute nightmare.
If you've been working with Kubernetes for a while, you already know the old way, Ingress. Trying to do a 5% canary rollout with Ingress meant wrestling with these messy, vendor-specific annotations. Maybe you were using Nginx or Istio or Kong. Each one had completely different, entirely incompatible custom setups. It was fragile, it was confusing, and it tied you completely to one single vendor. Contrast that with the new Gateway API. One clean, standardized YAML file, and the best part? It works everywhere.
The paradigm shift, moving beyond Ingress. We are looking at a total paradigm shift here, moving beyond Ingress. See, the Kubernetes Gateway API is the modern, official, vendor-neutral successor for managing how external traffic enters your cluster and gets routed to your internal services. Let's actually break down exactly why Ingress wasn't enough. First off, it lacked native support for traffic splitting, which, as we know, is the exact thing we need for our 5% canary rollout. Plus, it had no native support for header-based routing either. And because every single provider had to hack together their own custom solutions for this stuff, you ended up with tight vendor coupling. But honestly, worse than all of that, Ingress had zero role separation. Cluster admins and application devs were forced to edit the exact same Ingress resource. I mean, one typo from a junior dev could literally take down routing for the entire cluster. Just a massive security and operational risk.
The 3 core resources.
To solve this mess, the Gateway API completely rethought the architecture. They introduced 3 core resources to create a really clear separation of concerns. And this brilliantly illustrates how those roles break down. Let's use a real estate analogy. First up, we have the Gateway class. This is owned by the infrastructure team. Think of them as the city planner. They declare which infrastructure provider handles gateways for the whole city, so to speak. Second, we have the gateway itself. This is owned by the cluster ops team. They are like the building manager. They define the actual entry points, the open ports, and which namespaces are even allowed into the building. And finally, we have the HTTP route. This is owned by you, the application developers. You're the tenant. You define the routing rules for your specific app. Match this path, forward to that service. And you do it all without ever needing to touch the gateway or the gateway class. It completely solves that old Ingress role confusion.
The 7 levels of capability.
So how do we actually use this to solve those deployment fears we talked about? We're going to gamify this a bit. There are 7 progressive levels of capability we need to unlock to fully master the Gateway API. Let's start climbing. Level 1 is basic routing. This is your absolute minimum viable setup. An HTTP route matches a path prefix like /users and forwards traffic to the backend Kubernetes service, which then load balances across your ephemeral pods. Easy enough, right? Level 2 steps it up to path-based routing. Now, one gateway serves an entire microservices architecture. /users goes to the user service, /products goes to products. And because of that role separation, every team manages their own HTTP route independently. Level 3 unlocks header-based canary routing. The gateway evaluates rules from top to bottom. If it sees a specific header, let's say xcanary true, it routes to version 2. If not, it routes to version 1. So if you were to run a simple curl command passing that xcanary header right now, you would immediately see your terminal return the response from version 2, proving the route works before any real users ever see it.
And that brings us to level 4, weighted traffic splitting. This right here is the payoff to our opening hook. Instead of using a header, you simply assign weights directly inside your HTTP route rule. You put 95 weight to version 1 and 5 weight to version 2. The underlying proxy, say Envoy, natively and proportionally distributes the traffic.
Absolutely zero messy vendor annotations required. If you run a load test script in your terminal right now, your logs will show exactly 5 out of every 100 requests hitting the new version. That terrifying production deployment, it's completely tamed.
Moving up, Level 5 introduces TLS termination. Let's bust some jargon really quickly here. When users connect over HTTPS, the traffic is encrypted using Transport Layer Security, or TLS. Managing those certificates on every single backend service is just a massive headache. With the Gateway API, the gateway holds the certificate and the private key. It literally terminates or decrypts the connection right at the edge of the cluster, and then it forwards plain, unencrypted HTTP traffic to your backend services. This makes your backend services vastly simpler and way lighter. If you curl the HTTPS endpoint, your CLI will show a successful TLS handshake handled entirely by the gateway, not your app.
But wait, you might be wondering, where exactly is that TLS certificate stored? Well, in a Kubernetes secret, of course. But often, the gateway and that secret live in completely different namespaces. So, here's the absolutely crucial point. This new security boundary called the reference grant. It's a resource that explicitly authorizes the gateway to access a secret in another namespace. Without a reference grant, that cross-namespace access is strictly blocked to prevent any malicious activity. Actually, scratch that. It's not just blocked, it's a massive security upgrade for your whole cluster. If you try to deploy a gateway pointing to a secret without this grant, your Kubernetes event logs will immediately slap you with a strict access denied error. No way around it.
All right, moving to Level 6, rate limiting. Think about this. What happens if a broken script starts just hammering your API? Without protection, your backend crashes. Game over. But by configuring rate limits at the gateway level, let's say 10 requests per minute, the gateway steps in as a shield. When the limit is exceeded, the gateway instantly returns HTTP status code 429. That means too many requests. The excess traffic literally never even reaches your backend pods. Run a quick stress test from your command line, and you'll see those 429 status codes pop up right on cue while your backend stays perfectly healthy.
Finally, the boss stage. Level 7, Observability. Look, you simply cannot debug or optimize a system you cannot observe. It's impossible. The Gateway API emits structured access logs right to standard out, capturing everything. Paths, status codes, response times, the whole shebang. It also exposes Prometheus metrics, giving you real-time counters and histograms. This creates what's often called the golden signal layer right at the edge of your cluster. It's a single, unified observation point for all traffic, latency, and errors before it even touches your application code. Tail the logs of your gateway pod, and you'll see this beautifully structured stream of every single request flowing through your cluster.
Let's move to our final section, the final verdict, Ingress versus Gateway API.
We've seen what it can do. Now, let's put it head-to-head with the old way. Gateway API gives you native header routing and native traffic splitting. Ingress? Well, that requires vendor-specific hacks. Gateway API gives you explicit role separation across 3 dedicated resources so your app devs and infrastructure teams don't step on each other's toes. Ingress crams all of that into one highly dangerous file. Gateway API uses reference grants for secure cross-namespace secrets. Ingress handles this completely inconsistently. And best of all, Gateway API is entirely vendor neutral. The exact same YAML works for Envoy, Istio, Kong, and more. It is portable, it is secure, and for sure, it's incredibly powerful. We've covered a ton of ground today in this explainer, from surviving that terrifying 5% canary deployment all the way to mastering the 7 levels of the Gateway API. But honestly, the absolute best way to truly understand this is to get your hands dirty. So, my challenge to you is this. Set up a local cluster on your own machine and run through all 7 of these levels yourself. Really feel the difference of writing that clean YAML. So, are you ready to leave Ingress behind and finally level up your production deployments?